Hey everybody, welcome back to the Excel and graphing videos. This is video number 3, and this time we're going to be talking about adding best fit lines and error bars to your graphs. So what we want to do, we have a scatter plot right here, and we see that we've got what looks like a pretty linear relationship here, but it's not perfectly linear. The reason we think it's not perfectly linear is because of random error. In other words, it should be linear, and we could probably fit a line to it that would be pretty close to all these points. And any of the points that are not on the line, it's probably because of just random error, just random fluctuations or random changes that happens when we measure things. The universe isn't perfect, it's not mathematically perfect, but we can use the line of best fit or statistics. Line of best fit is a statistics tool to kind of eliminate that weirdness from the world and see how things are really happening. All right, so we want to fit this to a line of best fit. So first thing we need to do is select our data points, right-click, and choose Add Trend Line. This is going to open up the Format Trend Line dialog, and there's our trend line. We can change a couple of things here. The most important things we want to adjust are the type and showing the equation. I'll show you showing the equation first here. In the options, you want to change that to display equation on chart, and usually you also want the R² value on the chart. For the type, there are many different types that you can fit it to. And we'll talk in a moment about how to find the best type. We know this is pretty much a straight line, so we'll just leave it as linear. Keep this in, we'll come back to this later. All right, so that is a line of best fit. And we have our equation here and our R² value. And I'll talk more about how that looks in a second. I'm actually going to go back in here to show you some of the ways in which you can format your trend line. You have to click on the trend line, not on the dots, not on the data points, but on the trend line itself. Then right-click, Format Trend Line. So we can change a couple of things. One thing you might want to change is the size or the style of it. If you're making more than one line of best fit, you may want to change the style of it. You usually wouldn't want to have arrows or anything like that for it. You can also, well, you can give it a shadow, but you might want to change what the line itself looks like. So let me change it back to a nice straight line. Yeah, that's good. All right, now we want to talk about, what I want to talk about next is about how we can find the best relationship between our line and our data. And that all boils down to what this number here, R². R² is a number that represents how closely this line fits the data, or how close the data is to the line. It's basically based on how far these points are from the line. There's a whole formula that goes into that, but you don't need to know it. Well, you don't need to know it for science. You may need to know it for math, maybe. What you do need to know is the closer this is to 1, the better your fit is. This is 0.99542. Well, 0.995. That's really good. 1 is perfect. Every dot is exactly on the line. 0.995, really good. The higher this is, the closer your fit is. We can, if we're not sure what kind of equation we have, what kind of relationship we have between the data points, between the two variables, we can go to Format Trend Line, obviously click on the line first, then right-click, then Format Trend Line, and go to Type. And we can change what type we're using. There's a couple of, these 4 types are the ones I'd recommend to try out. Linear is a good one, if it looks like you have a straight line. That's the simplest type of relationship. In the next video, in the 4th video, I'm going to talk about how you can make your relationship fit a linear graph. The second one is power. Power fits to what's called a power curve. And a power curve will tell you what the relationship between the variables, what kind of relationship you have between the variables. For example, if you have a, let's say y is proportional to 1 over x, it will give you an exponent of -1. Let's see, and we got logarithmic is another one. Logarithmic is linear and power, I'd say, are the most useful. Linear is good when it looks pretty linear, and it's the one you always want to try to, well, depending on your course, you want to try to fit it to a linear graph by doing some mathematical processing to your data. You can make things fit a linear graph, and that's the ultimate one we want. Power is good for figuring out what kind of equation you have. Logarithmic's only good if you think it's liable to be logarithmic, and that doesn't always happen. Same thing with exponential. These are good for things like exponential. This is good for something like exponential growth. If you're working with exponential growth, use this one. Logarithmic would be sort of the same thing, but this is more like exponential. Isn't really. Anyway, use these two if you think it's likely. Polynomial is one you should stay away from because you can fit a curve perfectly by just adding more terms, but it doesn't mean anything. So I can make x cubed, x to the fourth, x to the fifth. And as I add more, as I increase this order, the r squared value, you might be able to see it there, keeps going up, but it doesn't actually mean anything. The linear is really good. I get 0.99542. So that's the one I'd choose. So again, the best ones to try, use linear if you think it's a straight line. Check that one out. Use power if you're not sure what you have to help you find what the sort of relationship is. Use exponential and logarithmic if you have a reason to. Don't use polynomial and don't use that moving average. I have no idea what that's for. I think that's more financial. That's not science. Now let's take a look at this formula here for the linear graph. This is an important one to read, and I'll also show you what it looks like for the power so you can read it. We have our y equals number, there's a constant here times x, and then another constant. All of you should already know the basic formula for a line. Y equals mx plus b. Well, this is your m. Your slope is right here. The slope of this line is 958.42. So that's 958 centimeters per second squared. Now, if I was to convert that, that's about 9.58 meters per second squared. Since this was a free fall experiment, that's pretty close to gravity, 9.81 meters per second squared. So this slope tells me what acceleration is, because this is a velocity versus time graph. This is going to be the value you're going to want to use all the time. The slope usually gives you the rate, and that's a lot of, it's really important for giving you the relationship between the two variables. Most labs you're going to do, most labs I assign, you're going to be using this slope to find some value. This here is the y-intercept. This can be useful. It's especially good for doing things like telling you, in this one it would tell me what the initial velocity was. Like, I know that I'm recording this data after the cart's been moving for a while, and the cart's, when I started recording my data, it was going about 53 meters per second. It can be useful, it's not absolutely essential. If we were using, let me switch this over to the power formula. The most important thing I want to look at when I'm using a power formula is what the exponent is. And that exponent is going to tell me what kind of relationship I have. If it's a linear relationship, and I'm not sure why this one isn't showing a linear relationship, this should actually be 1, x to the power of 1. I'm not sure why it's doing something different, but in any case, it's got a lower r squared value, so I don't really care. If it fits really well to something like x to the power of 0.5, 0.5 is square root. Negative means 1 over. It might fit it really well to x squared, in which case you've got an x squared equation. And you can use this to help you with linearization, which we'll look at next time. So I'll show you that when we get to that video. Let me switch this back to a nice trend line, linear trend line, 0.995. All right, so that's what we need to know about trend lines. The next thing I want to talk about is how to add error bars. Oh, actually, before I do that, I want to talk about this point right here. This guy right here. This point is way too high for my values. It's what I would call an outlier. It's really far off the graph. The rest of them are pretty close. Even this one that's just a little bit off is still fairly close. This is far off. My thought with this one is I don't actually need it. That it's not a good, there's something else going on here. It's not really supposed to be part of my value or of my data. So I want to eliminate it. The way we can do that is through select data. If I click on the data, and I right click, I get this option to select data. When I select data, it brings me back looking at the values here. And what I need to do, this is okay. This is the data source dialog, and this tells me what the data range is for my chart. It also shows me the series. Each series is a different set of dots on my plot or on my graph. If I had, for example, 3 trials, each one would be a different series. And I can also put in the names for these series, which is really helpful if you keep the legend, because normally the legend goes series 1, series 2, series 3, which is bad. It doesn't look like anything. But I can change the names here. I can type in what I want. I can call it trial 1. Trial. Now, for my X values, I don't want to include that first dot. So I just clicked on this one here. I clicked on this one here. This button will send me, will change this dialog so that I can now select the data I want. I don't want that first dot, 0.017 seconds. I want everything after that. I want everything from here to here. And then I click this again to lock it in. Then I need to do the same thing, same basic idea for the next one. But I'm going to do it from over here. There we go. One, and that's okay. And now you can see it's just cut out that last point. Everything fits. And by cutting out that early bad point, that outlier point, my slope changed to 982 or 9.82 meters per second. I just made that much more closer to gravity. So that's how you can eliminate, you can adjust your data series and eliminate bad outliers. Remember that you can hold control or command if you're on a Mac, as I am. That will let you select cells that aren't connected. So if you have a dot in the middle that's way too high, let's say this dot here was actually really high up like this, you could cut it out by selecting the first dots that are good and then the last dot that are good and leaving this one out.
Okay, so we've got a good line of best fit here. Unfortunately, we don't have enough time to put in the error bars, so they're going to have to go in our next video. That's video number 4. But that's it for now. Thanks for watching. Bye.